Hi, I'm Eman, and in this video, we'll be talking about neural networks and deep learning, its definitions, applications, advantages and disadvantages, and some related topics revolving neural networks and artificial intelligence development. Neural networks are simply mathematical models inspired by how the human brain processes information and arrives at conclusions. Using algorithms, machines can recognize relationships between data points, and over time, continuously learn and improve through training. Here are illustrations of neurons, which are the basic building blocks of both the human nervous system on the left and the neural networks of a machine on the right. A neural network is trying to mimic the interconnection of neurons, which are either activated or inhibited whenever a stimulus is presented. To give us more idea, here is an overly simplified illustration of how the human brain works. The stimulus or input is a cat or an image of this beautiful cat perceived through the human eyes. Neurons interact with each other through synapses. The human's brain instantaneously interprets the image. The thought process can be something in the line of, hey, looks like a cat, no, doesn't look like a dog, can be a tiger but no stripes, so not likely. Maybe a cow because of the black and white patterns in the face. Eventually arriving to the conclusion that it is a cat. Analogously, we can describe a machine's brain in such a way that an input, such as an image of a cat, is processed in a black box of neurons, mimicking the synapses of the brain through mathematical activation functions. In this scenario, the inputs are the image pixels, and the output is a calculated most probable conclusion. Behind the curtains, you would see layers of neurons interacting with each other to arrive at the most probable output. You can see here a simple neural network consists of the input layer, one hidden layer of neurons, and the output layer. So, how do we use the image of a cat as an input? Basically, we can treat the image of a cat as a collection of pixels, say a 25 by 25 pixel image, which would have 625 pixels, which would serve as inputs to the neural network. It then goes through the black box of the hidden layer where patterns and features of the image are figured out by the algorithm. There are mathematical models implemented in this layer that determines whether the neurons should be activated or inhibited, thus imitating synapses in the brain. Finally, calculating the probabilities at the output layer, taking the highest probability concludes the image is indeed that of a cat. What if the neural network has more layers? It is then classified as a deep neural network, more commonly known as deep learning. As illustrated, it has a lot of hidden layers interacting with each other. Formally, deep learning falls under the umbrella of machine learning and artificial intelligence. It is one of the tools used for complex data science projects. Applications. There's a wide range of applications which we are likely to be encountering in our daily lives. First is facial detection and recognition, commonly used in unlocking our smartphones. It can also be used for surveillance. On the right is a snapshot of the Chinese surveillance AI, which raised a few issues such as human privacy in the past years. On a positive note, this can be applied for public security, such as in terrorist detection or in selective entries in buildings, outdating the use of physical IDs and RFID scans. Stock market prediction. Opposing views exist whether the market is really predictable or not, but AI proves to be a more accurate method than older ones. Social media, such as in automated ads targeting, showing you items which you are inclined to order online, or showing you what images you are more likely to interact with. Aerospace and automobiles, such as autopilot self-driving technology and land and air traffic management and control. Military and national defense for automated targeting, soldier performance augmentations, and patrolling and scouting. In healthcare, such as in cancer detection, medical image processing and retrieval, and early detection of autism. Text, speech, and gesture analysis. Assistants such as Siri and Google. Translators, signature verification, handwriting analysis, and sign language interpretations. Disaster risk reduction, such as weather forecasting, and for social goods such as in social, environmental, public health, and other issues. Advantages. First three would be talking about practicality and applications. First, wide range of applications, as demonstrated, and some may not have been mentioned yet. Efficiency and task delivery. Machines may accomplish tasks that would take longer hours for humans. Continuous learning. A neural network is designed to learn and improve itself over time as more training data becomes available from actual predictions. The next three are advantages versus other machine learning and AI techniques. Feature engineering. It can generate a lot more features by itself, even combinations that are not expected to work. Multitasking. Complex models may be designed in such a way to produce multiple outputs. Performance. As more data becomes available for training, older algorithms may plateau performance, yet neural networks are observed to perform better. Disadvantages. Hardware dependence. As the complexity increases, the cost of enabling hardware and maintenance increases as well. This is tied to the complexity of algorithms. Programming is a lengthy and time-consuming chore. Some may require months to create an algorithm capable of working a specific task. It becomes more expensive in terms of computing power and the time and effort spent. Its black box nature, meaning human analysts and even the developers of the neural networks do not necessarily understand everything that's happening inside it. Data dependency. The benefit of neural network lies in the existence of large datasets and in the quality of the training inputs. Prone to overfitting. Because of millions or even billions of features and parameters it can possibly try to learn in training, just because it can. Lack of flexibility. Example is the image at the left. If machines can feel pain, then I suppose this is one of its headaches. Some related topics. Recent news surrounded Tesla's self-driving cars and the social humanoid Sophia. Try googling them. Are AI-enabled machines replacing humans? Data and AI code of ethics. Topics such as privacy, accountability, transparency, and readiness should be discussed. I would personally recommend Data Ethics PH podcast if you want to learn more from the expert. Also, in our country now, we are fortunate to have organizations initiating the talks and trainings about such important topics. One of them is the Analytics Association of the Philippines. The last one I personally labeled as the Blade Runner, from the movie Blade Runner. If you haven't watched the movies, check it out. It basically explores the topic of AI being able to imitate human consciousness, emotions, and biological processes. That concludes this video and I hope you learned something new today.